Right now, orbiting one of the strangest planets in our solar system, there is a moon so small you could walk around the entire thing in a couple of hours. It is roughly 10 kilometers across. That is smaller than most cities, smaller than Manhattan. A chunk of rock and ice drifting 2.8 billion kilometers from the sun, tucked inside a system of dark, narrow rings circling a planet that spins on its side. And for 39 years, nobody knew it was there. In January 1986, NASA's Voyager 2 flew past Uranus at a distance of just 81,500 kilometers, snapping thousands of images, discovering 10 new moons, mapping rings, measuring magnetic fields. It was the single most intensive look humanity has ever had at this planet. And it missed one. Not because the spacecraft failed, not because the team was careless, but because this moon is so small and so faint that even Voyager 2's cameras, even the Hubble Space Telescope, could not pick it out from the glare of the planet and its rings. It took the most powerful space telescope ever built, staring for nearly 7 straight hours to find what had been hiding in plain sight. But here is the part that nobody is talking about yet. This tiny moon is not just a number on a list. It may be a clue to one of the oldest unsolved puzzles in planetary science, a puzzle about why Uranus's rings look the way they do and what invisible forces have been shaping them for millions of years. Stay with me because this story goes much deeper than a single discovery. Subscribe now if you want space stories grounded in real science, not hype, because we are just getting started. Let's go back to where this story actually begins. On August 20th, 1977, NASA launched Voyager 2 from Cape Canaveral, Florida. The spacecraft was originally designed to visit Jupiter and Saturn. That was the plan. 2 planets, a few years of science, and then silence. But Voyager 2 had an advantage that only comes around once every 175 years. The 4 giant planets of the outer solar system, Jupiter, Saturn, Uranus, and Neptune, were aligned in a way that allowed a single spacecraft to visit all 4 using gravity assists, slingshotting from one to the next like a stone skipping across a cosmic pond. NASA approved the extended mission, and so Voyager 2 kept going. It reached Jupiter in 1979, Saturn in 1981, and then on January 24th, 1986, it arrived at Uranus. The encounter was brief. Because the trajectory had to be precisely shaped to allow a future flyby of Neptune, Voyager 2 had only about 5.5 hours of close study time at Uranus. 5.5 hours to photograph an entire planet, its rings and its moons under lighting conditions 400 times dimmer than what we experience on Earth. The sun was so far away that Uranus sat in a perpetual twilight, and because Uranus is tilted nearly 98 degrees on its side, the whole system looked like a bullseye from Voyager's approach angle, with the rings and moons orbiting around the planet's pole instead of around its equator the way we are used to seeing with Saturn. Before Voyager arrived, astronomers knew of 5 moons: Miranda, Ariel, Umbriel, Titania, and Oberon, all discovered between 1787 and 1948 using ground-based telescopes. In the span of that single flyby, Voyager 2 more than doubled the count. 10 new moons appeared in the images: Cordelia, Ophelia, Bianca, Cressida, Desdemona, Juliet, Portia, Rosalind, Belinda, and Puck, all named after characters from the works of William Shakespeare and Alexander Pope, continuing a literary tradition that dates back to 1852, when John Herschel, the son of the man who discovered Uranus, chose the names Oberon and Titania from A Midsummer Night's Dream. It was an extraordinary haul, 10 new worlds in a single pass. And it established something that scientists had only suspected. Uranus had a crowded, complex inner moon system, tightly entwined with its narrow, dark rings. But even that single pass, as productive as it was, had limits. And those limits would take nearly 4 decades to reveal themselves. For decades, planetary scientists had a persistent problem with Uranus. The rings did not make sense. Not the rings themselves, which are thin, dark, and narrow, nothing like Saturn's broad, bright bands. The problem was their edges. Uranus has 13 known rings. Most of them are remarkably narrow, some only a few kilometers wide. And those rings have sharp, clean edges. That should not happen. Left to their own physics, ring particles collide with each other, and those collisions spread the material outward. Over thousands of years, the edges should blur, the rings should widen, the whole system should slowly dissolve into a diffuse haze. But the rings around Uranus are crisp. They have been crisp for what appears to be a very long time. The explanation that planetary scientists developed is called shepherding. A shepherd moon is a small satellite that orbits near the edge of a ring and uses its gravity to nudge particles back into line. If a particle drifts too far inward, the shepherd moon speeds it up, pushing it back out. If it drifts too far outward, a shepherd moon on the other side slows it down, pulling it back in. 2 moons, one inside and one outside, can pin a ring between them and keep its edges sharp indefinitely. Voyager 2 confirmed this mechanism beautifully for one ring. The outermost and brightest ring, called the Epsilon ring, turned out to be flanked by 2 small moons, Cordelia on the inside and Ophelia on the outside. Their orbits were in exactly the right locations for gravitational resonances to maintain the ring's sharp boundaries. It was an elegant confirmation of a theory that Peter Goldreich and Scott Tremaine had proposed back in 1979. But here is the problem. The Epsilon ring is just one ring. Uranus has 20 sharp ring edges in total. Only 3 of those 20 edges have been explained by known shepherd moons. That leaves 17 sharp edges with no known mechanism holding them in place. A paper published in 2020 in the Philosophical Transactions of the Royal Society laid this out clearly. The authors noted that given 17 unexplained ring edges, several more moons should be required, likely in the 5 to 10 kilometer size range. Now stop and sit with that for a second. Scientists predicted, based on the physics of ring confinement, that there should be additional tiny moons hiding in the Uranian system. Moons too small for Voyager to see, moons too faint for Hubble to detect. And then, on February 2nd, 2025, someone found exactly that. But here's the part of this that stops being abstract and starts being personal. Uranus is not just a strange, tilted planet with unexplained rings orbiting at the edge of relevance. It is increasingly understood to be a template. When astronomers survey exoplanets, planets orbiting other stars, the most common type they find is not a gas giant like Jupiter or a rocky world like Earth. It is something in between, something roughly the size of Uranus or Neptune. These are called ice giants, and they appear to be the most common type of planet in the galaxy. We live in a solar system that contains 2 of them, and we have visited each one exactly once for a few hours with 1970s technology. Understanding how Uranus works, how its rings are confined, how its moons interact, what its internal structure looks like, is not just an exercise in cataloging our own backyard. It is the closest laboratory we have for understanding the most common kind of world in the universe. Every tiny moon we find, every interaction we map between moon and ring, feeds directly into models of how planetary systems form and evolve. And we are still in the earliest stages of that work. The discovery happened because of one team, one telescope, and a very specific kind of patience. Dr. Mariame El-Mutamid, a lead scientist at the Southwest Research Institute in Boulder, Colorado, heads a project studying Uranus's rings and moons. As part of the James Webb Space Telescope's Guest Observer program, her team was allocated time to point Webb's near-infrared camera, called NIRCam, directly at Uranus. NIRCam was designed to detect the faintest galaxies in the universe, objects billions of light years away whose light has been stretched into infrared wavelengths by the expansion of space. Turning that same instrument toward a planet in our own solar system is like bringing a surgical microscope to a task that everyone else had been doing with a magnifying glass. On February 2nd, 2025, El-Mutamid's team captured a series of 10 long exposure images of Uranus. Each exposure lasted 40 minutes. Over the course of nearly 7 hours, the telescope stared, collected photons, and built up signal. And in every single one of those 10 images, there was a faint moving point of light, drifting between the orbits of Ophelia and Bianca, following a nearly circular path around Uranus. Not a cosmic ray, not a background star, not an imaging artifact. A moon. A real physical object roughly 10 kilometers across, orbiting 57,844 kilometers from the center of Uranus, completing one full orbit every 9.6 hours. The team designated it S/2025U1. Heidi Hamel, a planetary scientist and astrophysicist who was not involved in the discovery, put the scale into perspective in an interview with Scientific American. She noted that this moon is so small that a person could walk around the entire thing. That image stays with you. A world so tiny you could circumnavigate it on foot, drifting through the dark, cold space between rings, invisible for 39 years, found only because the most powerful eye humanity has ever built happened to look in the right place for long enough. Matthew Hedman, a professor of physics at the University of Idaho and a collaborator on the project, helped confirm the detection. The research was funded through NASA's Space Telescope Science Institute under a Guest Observer Award. And on August 19, 2025, NASA made the announcement public. If you are the kind of person who finds the quiet discoveries as fascinating as the loud ones, go ahead and drop a like on this video right now because it genuinely helps this kind of content reach more people who would appreciate it. And this is where the discovery starts to get bigger than one moon, because S/2025U1 is not just the 29th entry on a list. It is the smallest moon ever found orbiting Uranus. Its estimated diameter of 8 to 10 kilometers puts it firmly in the size range that the 2020 ring shepherding paper predicted would be needed to explain those 17 unexplained ring edges. Its orbit between Ophelia and Bianca places it squarely within the inner moon system, the exact region where gravitational interactions with the rings are strongest. And its nearly circular orbit suggests it has not been captured from somewhere else. It likely formed near where it currently sits, which means it has been part of this system for a very long time, silently influencing the ring material around it. El Mutamid herself noted in interviews that the discovery raises questions about how many more small moons remain hidden around Uranus and how they interact with its rings. This is the thread that makes the whole picture shift. If one 10-kilometer moon was hiding in the inner system, there could be more, perhaps many more. A 2020 analysis calculated that if Uranus had unseen moons in the 5 to 10 kilometer range, Voyager 2's search had roughly an 80% chance of spotting any individual one. That sounds like good odds until you realize the flip side. For every 5 moons of that size, one would be expected to escape detection, and Voyager only had 5.5 hours of close observation. It was never designed to conduct a comprehensive census of objects this small. The rings of Uranus may be held in shape by an entire population of tiny shepherd moons that we have simply never had the instruments to see. And it gets stranger. A study published in Nature Astronomy in late 2024, led by Jamie Jasinski at NASA's Jet Propulsion Laboratory, went back to the original Voyager 2 data and discovered something unsettling. The flyby in January 1986, the single encounter that has shaped nearly everything we think we know about Uranus, appears to have caught the planet during a rare solar wind event. The solar wind pressure during the flyby was roughly 20 times higher than typical conditions. According to the analysis, the magnetospheric state Voyager 2 observed is present less than 5% of the time. In other words, the only close-up data we have on Uranus may represent one of the least typical moments in the planet's recent history. The implications are significant. The unexpectedly intense radiation belts, the strangely depleted plasma, the unusual magnetospheric dynamics, all of these observations that have defined our understanding of Uranus for 4 decades may reflect an extreme event rather than normal conditions. Linda Spilker, the Voyager project scientist who was among the original mission scientists during the 1986 flyby, acknowledged that the encounter was packed with surprises and that Voyager 2 had captured only a single snapshot in time. Now let's talk about what is happening right now. S/2025U1 will eventually receive a permanent name from the International Astronomical Union, following the tradition of drawing from Shakespeare and Alexander Pope. For now, it sits in the catalogs as a provisional designation, waiting to join a family that includes Titania, Oberon, Ariel, Puck, Cordelia, and Ophelia. But the larger story is about what comes next. The 2023 to 2032 Planetary Science Decadal Survey, the document that sets NASA's scientific priorities for the decade, identified a Uranus orbiter and probe as its highest priority new flagship mission. The original plan called for a launch in 2031, using a gravity assist at Jupiter to reach Uranus by roughly 2044. However, in 2023, NASA announced that a shortfall in plutonium production, the fuel needed for the spacecraft's radioisotope power system, would likely push the launch window into the mid to late 2030s. If it reaches Uranus, an orbiter would spend years circling the planet, mapping its gravitational and magnetic fields, studying its atmosphere and interior, and conducting a thorough survey of its moons and rings. It would find what Voyager 2 never could. But as of today, that mission has not been formally approved. No hardware is being built. The window is open, but it is not infinite. The Jupiter gravity assist that makes the transit time manageable requires specific planetary alignments, and those alignments do not last forever. Here is what I want you to take away from all of this. In January 1986, a spacecraft the size of a small car, running on a power source weaker than most household light bulbs, flew through the Uranian system at tens of thousands of kilometers per hour and discovered 10 new moons in a single afternoon. It was one of the great feats of robotic exploration. And it was not enough. 39 years later, a telescope sitting at a point in space 1.5 million kilometers from Earth, designed to see the first galaxies that ever formed, turned its infrared eye toward our own solar system and found a moon the size of a small town hiding among the rings. Not because the old data was wrong, not because Voyager failed, but because the universe keeps more than it reveals, and the tools we build determine what we are allowed to see. Uranus sits out there right now, tilted on its side, wrapped in dark, narrow rings held in place by forces we still do not fully understand, orbited by at least 29 moons and almost certainly more, spinning through conditions we may have only seen once and never under normal circumstances. One planet, one flyby, one snapshot in 40 years. And the more we look, the more we find that we barely looked at all. If this story shifted the way you think about what we still do not know in our own solar system, subscribe and hit the notification bell so you do not miss the next one. I am working on a story about what Webb is revealing about the moons of Uranus that may harbor hidden oceans beneath their surfaces, and that one is going to change the way you think about where life might exist. Drop a comment and let me know what surprised you most about this discovery. Was it the size of the moon? The fact that Voyager missed it? or the idea that the only time we ever visited Uranus may have been on the worst possible day. And share this with someone who needs a reminder that we are still discovering new worlds in our own backyard, because this story deserves a much wider audience than it is getting.